y'all. So we are going to be talking about area today, and it might be a review for some, it might not for others. So we're going to start simple. All of this is located on your MCAS reference sheet, FYI. So we're going to start with a square. The area of a square on your MCAS reference sheet is notated as that. S means side. So say I had a square here, it gave me this. So my side is 5 meters. So if we plug that into our area formula, what do we get? Yep. 25 meters squared. Remember, whenever we take the area, we have to square our units. So, square, get it? Okay, anyway, moving on. For our rectangle. Rectangle is also one that we should be familiar with. On your MCAS reference sheet, its area equals length times width. So say that I had a rectangle. It looked like this. It was 2 meters by 5 meters. What would we do? What would we get for our answer? Alright, so we have area equals 5 times 2. So we would get 10 meters squared. Nope, none of this was drawn to scale. So that's square and rectangle, which we should probably be familiar with. The next couple you might not be as familiar with. So next we're going to go to something called a parallelogram. So why do we think, what vocabulary words do we know that is in this title? Parallel. Parallel is in this title. So that's going to come into what the shape looks like. So the area of a parallelogram is B times H. So this is base times height. So say our parallelogram, they look something like this. So parallelograms mean all sides are parallel from what they're across from. So these two sides are parallel, and these two sides are parallel. So in this parallelogram, our base would be, depending on if we're looking at it this way, our base would be down here. If we were looking at it this way, our base would be here. So, in terms of this one, let's say our base is 5 meters. We still need our height. Our height, this is not our height. Our height has to be at a right angle from the ground or the base up. So if we make a right angle to the top, say this was like 6, you can either get it if it shows you this way, or sometimes it shows you this way. So these are the two places you can find that height. So we have the base, we have the height. What's the area? Area is 5 times 6, which is 30 meters squared. So a parallelogram's not that bad either. The next one we should have seen as well when we were doing trig and stuff, which is, what do we think? If I'm talking about trigonometry, we're working with triangles. So the area of a triangle is 1/2 base times height. Sorry, sometimes I do squiggly ones for these just because I'm so used to it. So, triangles you can see in 2 different ways. So the way that we're used to seeing triangles is something like this, where it already has that right angle because we performed SOHCAHTOA and the Pythagorean theorem and all these things like that. So say this was 3 meters, this was 2 meters, so our area is what? Alright, area is 1/2 base, which is 2, times height, which is 3, 1/2 times 2 times 3. The area is 3 meters squared. So that's what we're used to, but triangles can also look like this. So our base is going to be like this big thing at the bottom. So let's say our base is 6. But our height, it has to be the same thing like we talked about for our parallelogram. It has to come from the highest point, so this is the highest point, and an imaginary line comes down and hits at a 90-degree angle. So a straight line down. That's our height. So in this case, let's pretend it's 4. And these are given to you, or else it's on a coordinate plane, so you have to count. So you can always find that information. So what is the area of this one? All right, let's check. So area is 1/2 base times height. So 1/2 base times height, your area is 12 meters squared. So we're almost done. We have one more left. And this is the most complicated formula when it comes to area. So, this very last one we're going to talk about is our trapezoid. And this might look complicated, but I'm going to include a YouTube link, which is really, really cool, and it shows you how the different cuttings do, which you don't have to watch, but you can use to see why this formula works. So the area is 1/2 the height times base 1 plus base 2. So this is a little bit tricky. Something to note, the way you can find your bases is that they are the parallel sides. So we're talking about parallels for parallelograms. So parallelograms have two sets of opposite parallel sides. Trapezoids only have one set of parallel opposite sides. And that's the way that we find our area. So, let's say we have a trapezoid that looks like this. So, if we had to find our parallel sides, it would be these ones. It's pretty obvious because these are going to touch at some point. So, let's say this space right here is 6, this is 4, and this is 3. So I want you to try to plug this in and tell me what you get. All right, let's see if you're correct. So the area equals 1/2. The height is 3, so you can think about the height. It's in between the two parallel lines. It's how thick your sandwich is. So 3 times my base 1 and base 2 doesn't matter which order you put this in. So I'm going to put 6 plus 4. So remember with PEMDAS, you have to do parentheses first. And that means you have to do the operations inside the parentheses. So I have 6 plus 4. So I have 1/2 times 3 times 10. So my area here is 15 meters squared. So that's one type of trapezoid. You can also see trapezoids that look a little different. So I'm also going to put this one sideways. Just note, if you're confused, you can always turn your paper, your computer, whatever, so you can see it in a way that's easier for you. So let's see if I can even draw this how I want. Okay, I did. Alright, so this is another trapezoid. Note how these two lines would be my parallel lines. So say this is 10 meters here. This is 5 meters here. But wait, what the heck is the height? So this trapezoid looks weird. So I'm going to flip it. Oh, this looks a little similar. Well, we can do the same method we did with our triangle and our parallelogram, where from the height, we make a right angle with the base. And that is going to be our height. So that's why when I think about height, I like to think about how far away my sides are being sandwiched. So this is 2 meters away. That's why that's my height there. So try to plug this in and let's see what you get. All right, let's check. So I have area equals 1/2. My height is 2 times 10 plus 5. So I have my area is 1/2 times 2 times 15, because PEMDAS we have to add those first. So area is 15 meters squared. Note that these are very similar in answers, but they look very different. So that's just how to find area of all these different types. We're going to do one more thing with them, and we're going to kick it up a notch. Put a little spice on it, you know. Okay, anyway. So, we're going to talk about now compound or composite. Composite shapes. So, these are shapes that are made up of all the shapes we already know. So the big thing you need to know about these to find them is you want to break the shape up into shapes we know. And what I mean by that is, say we have something that looks like this. Well, I don't know how the heck to find this. So I'm going to give it its stuff. So this is not a shape that there's a formula to, so we need to make one. But if I want, I can break this up into shapes I know. So I'm just going to make it into 2 rectangles. So rectangles, remember, are length times width. So my length of this one is 10, and my height is 5, whatever. So this part is 50 meters squared. But then we have this part, and we don't know what this is. Actually, we do. We know that from here to here is 10, so that means 6 plus what gives us 10? 4. So it's actually 3 times 4, which would give us 12 meters squared. So we found the shape of our first rectangle, we found it of our second one. Now, we just add it up. So we get 62 meters squared. And you can do this for the most complicated shapes ever. All you have to do is break it up and put as many lines as you need to until you see shapes you know. Like, for one more example, here's a weird looking one that I made up earlier. Okay, so say we have this weird looking bird head. Well, we can actually still find the area. So how many shapes would you cut this into to find? What do you think? Some of you might have said 3, 4, 5, whatever. I'm going to cut it into 3 just because it looks easier for me. So I'm going to cut and make a rectangle up here. Okay, cool. Well, I don't know the shape about this one, so I need to make another one. So I'm going to cut again right here. Okay, I know that's a rectangle. What shape is this in the middle? A trapezoid, and then another rectangle. So I can find the area of each piece. So the area of this one is 50 meters squared, because I multiply these. The area of this one is 6 meters squared, because I multiply these two. Remember, this down here is going to be this area of the base plus this times the height. So 7, 8, 9. So I know this bottom is 9 because I added 7 in this 2. And this one I did wrong, but that's fine, and I'm running out of time anyway. So this one I technically don't have enough information to do because of this piece. So I can chop it up even more. So I'm going to chop it up like this into pieces I know. So, all right. So I know this is 2 right here. But what about this section? Well, I know I have this is 3. This is 5. So 5, 6, 7, 8. This has to be 2 as well. So 2 times 2, that's 4. All right, next one. Let's see if I have enough information for this. All right, I have this little tiny base here is 7. I have this little thing here. Can I figure it out? I can, because of this 2. So I have 2, which is from here to here. So that means this little section is 8. So composite shapes get very, very complicated in that you have to use all the different parts of your shape to find everything. So like, we had to use this bottom here to find this part 2. We had to find these 2 sides here because they match with these 2 sides to find this here. So all of those things go together. I'm not going to finish solving this one because I'm running out of time for my free recording, but complicated shapes, you just want to manipulate them as best you can. So if you have any questions, as always, email me. I hope to see you in class today. Have a good